I think we stopped on number 35. Yes?
Hey, which ones did you say weren't going to be on there?
We did it.
Yeah. Let's see here. 33 and 34, f plus g of 2, f minus g of 2, f times g of 2, and f divided by g of 2. Those won't be on there because they're a little time consuming in doing them. So we did 35 yesterday. Are there any questions on 36, 37, or 38? One of those that y'all want to see done. Yeah, we'll do 41 here in a minute. But there's one of these here, the composite functions, where we don't have a number plugged in. Okay. We want to look at 41, yes? So we have f of g, or g of f of g of f of g of 3. Okay. 7x minus 2. F of x and g of x is our negative 2x plus 5. Now, with any of these here, with any of the composite functions, we always start out from the inside and we go out. We work our way out. So even though we do have a bunch, so g of f of g of f of g, we have 5 different functions, I always start from the center and work my way out. So the first one I'm looking at is g of 3. So that means for my g of x function, I'm going to replace x with 3. So g of x is negative 2x plus 5. So I'm going to replace x with 3, which gives me negative 2 times 3 plus 5. Because I plugged 3 into g of x. Well, am I able to type in negative 2 times 3 plus 5 into the calculator? Well, yeah, we can simplify that. And at this point here, after we plug each number in, we want to simplify down if possible. And here we can. Negative 2 times 3 is negative 6. Negative 2 times 3 is negative 6. Plus 5 would be negative 1. And I mean, if we wanted to in the calculator, we do negative 2, parentheses 3, close parentheses, plus 5, hit enter, and it'll tell us it's negative 1. Any questions on this so far? Now we're going to do a similar thing, but this time we're plugging negative 1 into f, because that's what it's simplified down to. We got negative 1. So g of f of g of, well, I plug negative 1 into f of x, which would be 7 times negative 1 minus 2. Any questions on this so far? So we started off, we plugged 3 into g of x, simplified to negative 1. Now we plug negative 1 into f of x, and we've got 7 times negative 1 minus 2. And we need to simplify this here. Well, 7 times negative 1 is negative 7. Minus 2 would be negative 9. And again, whenever we're simplifying these here, we can type this into the calculator, because since it's all numbers, and simplify it down. Any questions on this so far? So we're just plugging the number in, simplifying, plugging it in, simplifying. I'm going to do it again. This time we're plugging negative 9 into g of x. So that would be negative 2, bless you, times negative 9, bless you, plus 5. So this time we're plugging negative 9 into g of x. Now we just need to simplify this here. So we can type it into a calculator, or if we do this by hand, well, negative 2 times negative 9, well, that's going to be positive. 2 times 9 is 18. And 18 plus 5 is 23. And again, working from the inside out. So now we're going to take f of 23. So that means we're plugging in 23 for x in f of x. So it would be 7 times 23 minus 2. Now 7 times 23 will be 161. And if we subtract 2, I think we should get 159. So if you typed it all into the calculator, you should get 159. So just type in 7 times 23 minus 2, and we would get 159. Any questions on this here before we do the last one? Well, the last thing we have is g of 159. So we'll plug 159 in for x and get negative 2 times 159 plus 5. 8 carry the 1. Negative 318 plus 5, I believe, is negative 313 is the answer. And that would be it. So the real main key thing for this here is just taking it one step at a time. We're going from the inside out. So we start out at the innermost function and slowly work our way out. Any other questions on these here? Any questions on any of these here? So are we good with these composite functions? Yes? Okay. Now the next one we want to look at is inverses. So are there any questions on (42) or 43 or 58, 59, or 60? Yeah. We could look at 43, because 43 is a little bit more to it. Now, if we look at this here, the first thing we can do is we're going to rewrite g of x as y. Because whenever we're finding the inverse, we first start off by replacing g of x or f of x, whatever we have, with y. Now, the next step that we need to do is we need to switch x and y. So this would become x is equal to 2y cubed minus 7. Now, what would we do after that? We really want to start off, if we can add or subtract, we want to do that first. Then multiplication and division, and we really want to try to leave radicals or exponents, applying exponents to both sides or applying radicals to both sides for the end or until we absolutely have to. Now, what would we do next to get y by itself? We would divide by 2. And if we divide both sides by 2, we get that y cubed is equal to x plus 2, x plus 7. Y wrote 2. This should be 7 x plus 7 divided by 2. And I can scroll down a little bit. Then we would cubed root it because we need to get rid of the third power attached to y, so we would cubed root both sides. Because the cubed root and cube would simplify, leaving us with y by itself is equal to the cubed root of x plus 7 divided by 2. Well, we would really want to write it as g inverse of x is equal to the cubed root of x plus 7 over 2. And the reason we use g inverse of x is because we started out with g of x. So if this had been f of x at the start, our final one should have been f inverse of x. So we kind of keep with the same notation. Any questions on any of these here? Okay, let's look at solving equations, solving these radical equations. So this one here is the first one we're going to look at. Now, whenever we solve radical equations or equations with radicals in them, we need to get the radical by itself first. So if we're looking at problem number 44, what is the first thing we need to do to get the radical by itself? Or is it already by itself? It's already by itself. There's nothing being added to it, subtracted from it, multiplied by it. It's already by itself, which means we can put both sides to the second power, because whenever we square a square root, they cancel out, which would leave us with 2y equals 8 squared is 64. Now what do we need to do next to solve for the value of y? We need to divide both sides by 2. And this here tells me y is equal to 32. And that's it. That's all we have to do for this here. Now, we only need to check it if the directions tell us to check our answer, because if it says to check your answer, you need to check it. There will be points assigned to it if it says it in the directions. Any other questions on 44? Any questions on 45?
So the reason in there you could be able to put it in parentheses with the second power, or
Let's go on and solve it. So what would we do first? We need to subtract the 7 because the radical is not by itself. And 15 minus 7 is 8. So whenever we're doing any of these here, we need to make sure the radical is by itself. Since we're adding 7 to the radical, we need to subtract it from both sides first. Now what would we do next? We would square both sides, because after we subtract 7 from both sides, the radical is by itself. There's nothing else with it. We do have things inside the radical, but we can take care of those later. Now the square root and square would cancel, leaving us with y minus 4 is equal to 64. And then we would add 4 to both sides to get y by itself, because these would cancel. And this would tell us that y is equal to 68. Any other questions on these two here? Any questions on 46 or 47? Any questions on these two here, or how to do these, or wanting to see how to do either one of these here?
So is that so 46 is that's when you would move stuff on it, or
Well, we would need to move stuff first. So what would we need to move first? So we can subtract 27 from both sides. And if we do that, we would get 3 square root of 2x plus 7 is equal to negative 23. And then what would we do? Divide by 3 because the radical is still not by itself. And that would tell me that the square root of 2x plus 7 is equal to, well, negative 23 over 3. Now at this point here, this problem is going to be a no solution because I cannot have a radical equal a negative number. Because once we get the radical by itself and it's still equal to a negative number, it's a no solution because I cannot take the square root of a number and get a negative number. It just does not work that way. Now, let's see here. Okay. '51. Let's look at 51 and then we'll look at 50. So if we're looking at 51, we need to get the radical by itself first. Well, what's the first thing we can do? Subtract 19 from both sides. The 19 and 19 will cancel. And that leaves us with negative 4 square root of 3x minus 11 is equal to negative 8. Is the radical by itself? No. So what do we need to do to get the radical by itself? Well, not just 4. Divide by negative 4. And if we divide both sides by negative 4, we get the square root of 3x minus 11 is equal to positive 2. So even though after we subtracted 19 from both sides, we had a negative number, once we divided both sides by negative 4, it turned it back to a positive number, which means we can solve this. This will have a solution. So our next step would be to square both sides because it is a square root. A square root and square would cancel, leaving us with 3x minus 11 is equal to 2 squared would be 4. And then what can we do next? 11, add 11 to both sides, which tells us 3x is equal to 15. And last but not least, divide both sides by 3, which tells us x is equal to 5. Yep. And that's all we have to do for this one here. Any other questions on this one here before we look at 50? All right, let's look at problem number 50. So the square root of 3 minus s is equal to s minus 1. So looking at this here, is the radical by itself? Yes, there's nothing else with the radical. So it means, since it's a square root, we can square both sides. Now the square root and square will cancel, leaving us with 3 minus s. Now we have s minus 1 squared. Well, that's the same as s minus 1 times s minus 1. This is being multiplied by itself. And we're going to have to distribute. We're going to have to multiply this all the way through. So we're going to have to do s times s, which is going to be s squared. S times negative 1 would be negative s. Negative 1 times s would be negative s. And lastly, negative 1 times negative 1 would be plus 1. Any questions on this so far? Now we can combine like terms. So 3 minus s, so over here. Over here we're going to have s squared minus 2s plus 1. Now, because we do have a quadratic, we have s to the second power, we do need to get everything on the same side of the equal sign. So what's the first thing we can do? We can add s to both sides. And if we add s to both sides, we'll get 3 is equal to s squared minus s plus 1. And then what? Minus 3 from both sides, because again, we need this equal to 0. S squared minus s minus 2. Any questions on any of this here? Okay. Well, now that we do have a quadratic, we can solve this by factoring, and we have it set equal to 0. Since the third term is negative, our signs are going to be opposite. One's going to be positive, one's going to be negative. The factors of s squared are s and s. And the factors of 2, 1 and 2, are the only ones we have. Which one's going to be positive? Which one's going to be negative? Positive 1 and negative 2. Because the middle term is negative, and because we don't have a number with s, we can really see which one's positive, which one's negative. Because negative 2 plus 1 would give us a negative 1. Because we want the bigger number to be negative. Now we do have two things multiplied together to equal 0, which means one of them has to be 0. So either s plus 1 is equal to 0 or s minus 2 is equal to 0. And at this point here, we can solve for the value of s by subtracting 1 from both sides, which would tell me s is equal to negative 1. And here we can add 2 to both sides. Tells me s is equal to 2. So these are the two answers that we get. Now, especially when we have a variable outside the radical, we need to plug it in and check to see which one works, because most likely one of these will not. So if we plug negative 1 into the original function, we'd have the square root of 3 minus negative 1 is equal to negative 1 minus 1. Well, 3 minus negative 1 would be 4, is equal to negative 2. Square root of 4 is 2. And well, 2 is not equal to this negative 2, so it does not work. Now we can plug 2 in. 3 minus 2 is equal to 2 minus 1. Well, 3 minus 2 is 1. 1. 1 is equal to 1. It works. So the answer for this is 2. Any questions on this here? Any questions on this here? Any questions on problems 44 through 57? Any other ones of the solving radicals that y'all want to see work? So are we good with 44 through 57? These solving radicals. Solving with radicals. Yes? Okay. If we're good with those there, I'll go 52, 53. 58, 59, and 60. Is there one of these three here that y'all want to look at with finding the inverse? Any one of these three here that y'all want to look at finding the inverse of the given function? Any questions on those there?
Show me how to do it.
Which one?
59.
59. When we look at this here, the first thing we're going to do is we're going to rewrite f of x as y. After we do that, we're going to switch x and y. And now we're going to solve for the value of y. We're going to get y by itself. So the first thing we can do in getting y by itself would be to add 3 to both sides. When we add 3 to both sides, we'd get x plus 3 is equal to 7y squared. Back up. Now, our next step in getting y by itself would be to divide both sides by 7. Because when we divide both sides by 7, it would simplify down to just y squared is equal to x plus 3 divided by 7. And last but not least, we still need to finish getting y by itself because we do have y squared. So we'll need to square root both sides. And y is going to equal the square root of x plus 3 divided by 7. Now, because of this general function, or the function we started out with, and x being greater than or equal to 0 is what it stated, the domain is positive, the range would be positive, so our inverse would be a positive. We would not consider the negative case. So we have f inverse of x is equal to the square root of x plus 3 divided by 7. And most all the ones I believe are on the test won't have the plus or minus. I'm not going to make too big of a deal about plus or minus for this test here when you're finding inverse. Are there any other questions on this here? So are we good with finding inverse? Yes? Okay. So the last thing we're going to look at is this one here. Determine if the following two functions are inverses. And what we're going to do to show this or find this out is we want to see if f of g of x is the same as g of f of x is x. Because if f of g of x gives us x and g of f of x gives us the value of x, then these two functions are inverses. And so that's what we're going to need to do. We're going to use these composite functions to show that these two functions here are inverses. Now, g of x is what? X squared plus 3 divided by 7. So that's what we're going to start off with, is we're going to plug x into g of x. X squared plus 3 divided by 7 is where we're going to start this off. So we plugged x into g of x and got this here, x squared plus 3 divided by 7. Now we're going to take f of x squared plus 3 divided by 7, which means everywhere there's an x in f of x, we're going to replace it with x squared plus 3 divided by 7. Now we do need to simplify this here a little bit. So any questions on this here before we start simplifying? Well, here, the 7 and 7 would cancel because it's 7 over 7 when we multiply. So those would simplify out. Now what that would leave us with is the square root of x squared plus 3 minus 3. Well, 3 minus 3 is 0. That just leaves us with x squared. And the square root of x squared is x. So this here, we're able to show that f of g of x is equal to x. Any questions on this here? Okay. Well, if we show one direction, we do still have to show the other direction. Erase this here so I have a little bit more room. So f of g of x worked. Now we need to see what g of f of x is equal to. Now, as we just said, f of x, when I plug x into f of x, I would get the square root of 7x minus 3. The square root of the quantity of 7x minus 3. Now again, just like we did before, this time we're plugging the square root of 7x minus 3 into g of x. Every place there's an x, so it'd be... Let me try this again. Parentheses, square root 7x minus 3 squared plus 3 divided by 7. So we're squaring, since g of x had x squared, we plug the square root of 7x minus 3 in for x. So we end up getting the square root of 7x minus 3 squared. Now, as we know with square roots and squares, the square root and square would cancel, leaving us with 7x minus 3 plus 3 divided by 7. Any questions on this so far? Well, the negative 3 plus 3 is 0, so we have 7x over 7. And 7x divided by 7 is x. So this means f of g of x is equal to g of f of x, which is equal to x. So these two functions here are inverses. So it works out that they are inverses. Okay. Are there any other questions on any of this here? Are we good with all of this here? Yes? All right. Are there any other questions on any other problems on the review sheet? Any other problems that y'all want to see work? Okay. If y'all are good with that